So welcome back again to the course. So in the last lecture we have seen the basics of static timing analysis. So in the static timing analysis there are different terminology which are associated with that we have seen. Along with that there are several comments which you can put that we have seen. So whatever comment is there that you can use in design compiler as well as prime time both. Prime time we use to calculate the delay information or the timing information more accurately, right? So that means here we will use, in the last demo we have seen that we have saved two different file. One is that constant file, another one is that corresponding Verilog file. So in the last class what we have saved, so that now will be used in the prime time. Okay, actually here we are considering only the basic example of one 16-bit counter, but the additional material, that means the script for doing advanced analysis of timing, all these things will be that means provided to you as a supplementary to this course, that means as an assignment or course material or tutorial to this course. Okay, so now we are moving to the demo on prime time. Okay, so to start the prime time, what we have to do, that means again the same thing we have to do, that is CSH, then source where we have that means save that CSHRC file where we have written all these paths information about this software, that is okay. Then we have to go to my home directory path. Okay, so there you just write prime time. So whenever this you just type this prime time, this GUI will come, and here you see this is more quite seems like design vision, but there is a difference. So here you see there is no such operation like you have that setup option or read option or something like that. So here everything you have to do it using script file or command line interface. So that's why from the beginning what I did, I have written one script file to be run on that prime time. So initially what we are doing, we are just like this, that means design vision what we have done, that means we have set the library information, and remember one thing, that means whatever library we have set there in design vision, the same library will be used here also. Why? Because the netlist file has been generated based on your target library. So if you change the target library now, so your that means design will not work. So that's why the target library, link library, both will be same what you have used in your design compiler environment. So after that what you have to do, I have generated the corresponding Verilog file there. That means I have already got the netlist file. Okay, so now that netlist file I will read into this prime time environment. In design compiler what we are doing, we are basically reading the generic HDL, that means file, Verilog file or VHDL file. Well, here we will that means read the corresponding netlist or synthesized and optimized netlist file which we got after this DC environment, right? So here using this command read underscore Verilog with the corresponding folder name and the file name, we are basically reading the synthesized netlist file. So after that we have to set the top module name. That means here this top module name is, as you see this so this one is my that means netlist file. So here you see the top module name is counter underscore 1. Okay, so that's why I have set that current design name as counter underscore 1, as the top module name is counter underscore 1. So after that what I have to do, I have to link this Verilog file with the library file which I read. Okay, so if your library is that means different, that means if there is a mismatch, so at that time during the linking it will show you the that means warning, or it will show you the errors. So after linking, that means now your netlist file and this library both are basically loaded into the that means memory of prime time. So after that you have to provide the information about the timing which you have that means used during the optimization or during the synthesis procedure. So that I have already saved with the name of .sdc, so Synapse design constant file. So now that you have to again read in the prime time environment. So you can read it, or what you can do, you can just one by one you can just type it. For advanced version of timing analysis, you can put some other that means timing information to see the timing information whether they are correct or not. That means hold time violation, setup time violation, and all those things you can check here in these things by putting some extra comments to that. But while we are synthesizing our design, so at that time what are the basic constant I put based on my specification, so that will remain intact, that will not be changed, or that you will not, that means allowed to change. So if you change, then at that time that means the information which you are getting at design compiler and what the information you are getting here, both will be different. So there will be no match. So at that time that means the chip may not work, or it may work, but you will get one, that means wrong message from the tools. Okay. So after doing that, you have to read the design constant file. So once you read the design constant file, then you check what is the, that means report timing. Okay. So I have just I have wrote all these comments in a script file. So the extension is .scr. So now what I will do, one by one here in this command line prompt, I can just, that means I can write and then press enter, one by one it will do. Or else what I can do, I'll just go to the file, then this execute the script. So here this one is the script pt.scr. So once I do that, so automatically one by one it will do. So if I go back, then you see that okay, it is not showing that one by one it is doing. So but here actually after at the end of this I have just mentioned, and okay, this report timing, so it is showing me the timing violation, that means it is that slack is violated here. Okay, so that is 0.88. so how can I, that means now in prime time how can I set that? So I can set in the design constant file, basically it is mentioned. So you see actually what is there, that data required time is 2.94 and data arrival time, actual arrival time is 3.81. So I am getting the slack violated of 0.88, that means it is near about 4. Okay, so though I have said that as 3. So here I have to set that period, I have to change that period as 4 and it will be now 2. Okay, so rest of the things are okay, all okay. So after that you just save this, and then again you just execute the script. So that means now I have changed in the design constant file, because whenever I am sourcing this design constant file, so it is basically taking all the information under which comes under the design constant file. So I have created the clock in design constant file. Okay, so that's why whenever I am again re-executing this script file, so again I have changed in the design constant file, now again it will be, that means becoming. So now it is changing to this, the design is already okay, so I don't have to link it again, so that's why it is showing the error. But here you see that the data, as I have changed the corresponding clock period to 4, so now this slack is met, and that is 0.12. So that means now as I said as 4, that means by 0.12 again I can reduce it. So that means that actual time will be, I think that actual time will be by 4 minus 0.12, that is 3.88. Okay, so 3.88 means what again what I have to do. So here in these things I have to set it as like 3.8, and here it is 1.9 and then save it, and then again you just execute the script again. Okay, so again actually it is showing me minus error. That means I have to again I have to select 8 point something, so 8.8, so 8.8, so it will be 1.94. so I have to save it, and here you again execute the script. So here you see that slack has been met with 0.0. Now if you want to see, that means this timing analysis. So here we are doing report timing, means this whether that is check timing or these things. So in the check timing operation, so there are so many things. If there is any clock latency override, so whatever you will select from this particular box, whether there what is the load information, whether there is no clock which is connected at any registers, or this multiple clocks are connected on the register clock pin. So each of these options is there which you want to check. So if you just click on this, that means if you check that thing for your design, so automatically in GUI you can check it. Okay, but we have already checked it, that okay, so report timing is basically giving me that that whether I am getting the timing information correctly or not. I have to see the whether that is the slack is met or not. Okay, so after that, if you want to see the corresponding slack information, so suppose from where is that clock, to okay, so here if you want to see that which path is basically taking the maximum skew, and here you see that the skew is 0, as I have not said that thing as I have not said that thing. So slack is met, and this value of slack is very actually that is very much nearer to 0. So this value is, that means this is the maximum time, or this is, that means 3.88 means this is the maximum operating 1000 divided by 3.88. this is the maximum operating frequency where this your counter 16-bit counter can operate on. So if you want to see, then you just click on this, so automatically you will get the information whatever you see in design vision. So that means here you see one thing, that means the design constant what I that means set in design compiler, basically that is not actually, it is not meeting here in that means in prime time. Okay, I have to change it. So that means there whatever timing information we are getting, that is not the actual one. Here it is calculating more, it is considering this RC relay and all those things for net and gate both. So here the timing information has been calculated and it has increased. So there was, I think, 3 nanosecond, now it became 3.88 nanosecond, the actual one. Okay, so and that is also after synthesis. So whenever that will be physically mapped, and again I'll generate that that means delay information, parasitic information, and actual parasitic information, and I'll put to that prime time. So again it may change. So after that means again it is a loop. That means now again I have to go back to the that means the design vision, and I have to check I have to change the corresponding constant value, clock constant value to 3.88. Then again I have to resynthesize the counter module, I have to generate the that means netlist file again, and then again I have to come back to the prime time and I have to see that okay, that 3.88 now it is okay in prime time, that means whatever netlist file I have generated, that is okay in prime time or not. So once it is that means okay, then I can move on to the next, which is the physical design of it. That means that netlist file now I can use, and that constant file now I will use for physical design. Okay. So this is actually, and you can see that there are several other advanced options like this crosstalk, then noise analysis, then power analysis. Okay, these are the advanced. That means whenever I'll actually calculate the signal integrity part. So at that time this crosstalk analysis, this noise analysis, this will come. And another thing is that there is one option, that is power. So power, how can I calculate? So power mode I have to, that means set power analysis mode true. I have to set fast. Then I have to calculate, or I have to give the corresponding switching files to it, and actually I have already read the netlist file, right? Then I have to give the switching information to that. Then if I write the okay report underscore power, then it will show me the power. Okay. But as we are not covering the simulation that means aspects here, so that's why I cannot, unless and until we are doing the simulation, I cannot generate, that means I am not applying the test vectors, so I am not able to generate the switching file, that means switching activity file, which I will put here to show you that okay, these are the power consumption is happening because of the dynamic power. So what I will do, I will provide that information or that part as a that means supplementary to this lecture. Okay. So this is actually this is the end of this prime time, that means after, that means this is called known as post synthesis timing information. Okay. So post synthesis timing information up to this one, then we will go to the, that means physical design part. So physical design demo we will see, or we will that means whatever this counter 16 module we have generated, we will generate the layout for that, auto layout for that, and then we will, that means calculate all the parasitics and all those things we will that means calculate, and again we will with that parasitics now we will come to prime time and check the timing whether that is meeting or not. Okay. So thank you. This is the end of the prime time demo.